Hello, math friends. Welcome to A Squared Math and Stuff. In these examples, we are taking a look at one-sided limits. So what exactly is a one-sided limit? Well, so far we've been looking at as x approaches some number. But now what we're going to do is we are going to take a look as x approaches some number, but coming in from the left or the more negative side, and then coming in from the right or the more positive side. And there's certain symbolization that we need to use to indicate this. So we're going to introduce the limit that comes in from the left-hand side. So limit from the left and how we write that. So that is written as the limit as x approaches whatever value we're looking at, so our constant, our c value, and that's coming in from the left-hand side or the more negative side. So we put a negative sign in the exponent position. So we're looking at the limit as x approaches c from the left-hand side of our function. And we're going to say that would equal some value or limit 1. And then we look at the limit as it comes in from the right. So limit from the right. And instead of a negative sign in that exponent position, we put a positive sign or a plus sign. So that means we're coming in from the positive side of the graph and taking a look at our function and looking to see what its y value approaches or limit to. So in order for one-sided limits to have an actual limit, your limit 1 and limit 2 need to be the same. If limit 1 and limit 2 are not the same, then the function at that x value does not have a limit. So let's take a look at this first example here. This first example deals with an absolute value, and again, we always want to just plug and chug. Let's substitute in 2 and see what we get. So we'd have 2 minus 2 absolute value all over 2 minus 2. Well, that ends up being 0 over 0. So again, we have this indeterminate form. And the indeterminate form means that we need to look at it in a different approach. So we need to simplify this somehow. We don't have a way to factor this, and we cannot rationalize it. So because we can't do either of those things, we are going to take a look at the limit from the left and the right, so the one-sided limits, and see what happens, see if we get the same value. So in the past, we've always worked with values that get arbitrarily close to our C value. And if you recall working with the tables, we got to 1/1000th of a decimal place close above and below to the C value. And that's what we're going to do here. So we're going to go 1/1000th closer in both the positive and the negative direction. So let's take a look at the limit as x approaches 2 from the left-hand side of the absolute value of x minus 2 all over x minus 2. So if I'm coming in from the left, that means I'm looking at numbers that are less than 2. So I'm going to plug in 1.999. Let's go ahead and do that. We'll do 1.999 minus 2. That's the absolute value of those, divided by 1.999 minus 2. And as we work through this, we end up with the absolute value of a negative 0.001, all divided by negative 0.001. This absolute value makes us positive. We keep the negative here. We have the same value. We end up here with just a negative 1. We're going to do the exact same thing coming in from the right-hand side now. So we'll change this to a positive, and we're going to go 1/100th larger than that 2. So looking at the limit as x approaches 2 from the right-hand side of x minus 2 all over x minus 2, or absolute value of x minus 2, and plugging in the absolute value of 2.001 minus 2 divided by 2.001 minus 2. We end up with a 0.001 absolute value, all divided by 0.001. Oop, extra 0 in there. So in this case, we have a positive divided by a positive, and we end up with 1. We have a negative 1 and a positive 1 in this case. Because these are different, our limit does not exist. So these are different values. Therefore, the limit does not exist. If we take a look at this in terms of a graph as well, if we look at our y, plug in the y equals, we have absolute value of x minus 2 divided by x minus 2, and then we graph this. As we approach that x equals 2 position, you can see that there's a jump in the graph. So as we've come in from the negative side, or the left-hand side, and we follow this graph, we stop at the y value of negative 1. If we come in from the positive side, or the right-hand side, we stop at a value of y equals positive 1. So because there's a jump here at that exact same x value, we do not have a limit. Let's take a look at a piecewise function. So with a piecewise function, we are given two different equations, and we are told what equation to use when we come in from the left-hand side, or when x is less than 1, and from the right-hand side when x is equal to or greater than 1. So let's go ahead and calculate those one-sided limits, because we don't have just one equation to plug it into. Let's see if our left-hand side and our right-hand side approach the same value. So the limit as x approaches 1 from the left means we are looking at 2x plus 1, because x is less than 1 here. So we're looking at numbers that are less than 1, so we're using this top equation. So 2x plus 1. Now we can substitute in 1, because we only have, we can substitute in 1 because we have two different equations here. Above here, we only had one equation, and if we plugged in 2, you would have gotten 0 over 0, so that meant that we have to do something different. Here, when we plug in 1, we do not get 0 over 0, because we just have a linear equation here. So let's just plug in 1, and we get 2 times 1 plus 1, or 3. Now let's take a look at the limit as x approaches 1 from the right-hand side. So from the right-hand side, we're looking at numbers that are larger than 1. Numbers that are larger than 1 say that we use the second equation, 4 minus x squared. So 4 minus x squared. Again, this is a parabola. We don't have a denominator. We won't have indeterminate form. So let's go ahead and just plug that 1 in. So we get 4 minus 1, or 3. So both of these values are the same, which means that we have a limit of 3. So the limit as x approaches 1 of our function is equal to 3. If you like what you saw, go ahead and click that subscribe button, and I will be chatting with you later.